Okay, next we'll check out some logarithmic equations and how to solve these. The first one I wanted to start with is fairly basic because we can simply use what the definition of a logarithm is. So I often teach it to think of 5, so I'm reading the base here to some power, so I read kind of up and right. 5 to some power equals x. Well, we have that power here. So really the way to rewrite this logarithm into an exponential function is 5 to the 4th equals x. And then we could just, multiply that out and we get x equals 625. Now, what I'm going to use to demonstrate it on this easy example, what I'm going to use from here on out is a different way of thinking of a logarithm. Like if we have an equation, how do I get rid of a log, right? What is the inverse? So it's kind of strange, but we have this old property that says, so let me go ahead and rewrite this equation again. Log base 5x equals 4. Okay. We have this rule that says if I have the same base raised to the logarithm of that base, that they do in fact cancel. So therefore, it's quite strange, but remember, whatever you do to one side, and if you do it the same thing to the other side of an equation, then it's allowed, right? Like if I add 2 to one side, I have to add 2 to the other side. So if I raise everything to the exponent and 5 becomes the base on both sides, then that's allowed. And why am I choosing 5? Because it's base 5 and these cancel. And just like this one here, right? I had 5 to the 4th equals x. So I'm going to use that technique for the following. So the one below, I can jump straight into that. And in fact, we could just rewrite it like we did the top one. But the two on the right, these two, we cannot quite do that yet. So, all right, we're going to make 2 the base. That way 2 raised to the log 2 cancels. And then I have to raise 2 over here. Again, we could do that because I have one term here, right? Even though it's a bunch of stuff in the parentheses, it's just one logarithm. So the 2 log 2 cancels, and we get 10 plus 3x equals 2 to the 5th, and 2 to the 5th is 32. Okay, subtract 10 and divide. This is our exact answer. Stepping back for 1 second, always with logarithms, double check that your answer works, right? Because remember, a logarithm, we cannot take logarithm of a negative value. It must be greater than 0. So if I kind of eyeball 22 over 3 in here, it's going to work, right? I mean, it's positive. As long as my math is correct, I'm good to go. But I highly recommend double checking all of your solutions. All right. The next example, we just have log, no base, right? Which means it's a 10. If no base is written, it's automatically a 10. But one common mistake I see often is like, all right, to get rid of this log, I just do 10, and then I do 10, and then I do 10. But it doesn't distribute that way. It's a function, kind of like when we did ln on both sides of an equation. You can't just ln each term individually. Just like if you have a square root, right? Like let's think back to some quadratic equation. You can't just square root every term either, right? It's like it's a square root of this entire thing if that's the way you would do it. Of course not for that problem. But I like to revert back to functions that we're familiar with to explain with what we are doing now. You cannot square root each term individually. You cannot take the logarithm each term individually. and we cannot raise each power of 10 right there. But we have properties of logarithms to make this a single logarithm. If I have log base 10 and a log base 10 with a plus, right, then I could change this to one logarithm and do multiply. Okay, plus becomes multiply when I have multiple logarithms with the same base. Now I could proceed, right? Now I could raise both sides to that 10 to get rid of this log because I have a single log, right? It's a log outer parentheses of all of this inner stuff. We can now do that. So the next step, I'm going to go ahead and distribute this x to the x minus 9. And 10 to the 1 I know is 10, right? But notice I have a quadratic. Let's go in and just subtract that 10. 10 to the 1 is 10, but I brought it to the other side. That way we can factor, right? X minus 10, x plus 1. So therefore x equals 10 and x equals negative 1. Again, always check your answers. If you get a negative, it's for sure wrong. The other ones you should definitely substitute it in and make sure your math is correct, right? But I'm not saying that x cannot be negative. I'm saying when you plug it in, it can't be negative. So for this example, because I have log x right here, right, I would have log negative 1. You can't do that. So automatically, we know that is not a solution. If I check 10, it's going to work. Log 10. 10 minus 9 is a positive 1. And you could go through with the arithmetic at that point to make sure it does in fact check out, but it will. So we get one solution, x equals 10. All right. So again, using our properties of logarithms, for this next example, the difference though is we have a subtraction here. Well, and I guess that we have a different base, right? We have ln log base e, but that's okay. So subtraction becomes division, but still it is reduced down to a single logarithm. Now what's interesting in this problem is the fact that the base is e, so when I create e here, we actually get the e and ln to cancel on both sides. Right? Over here I still had this power of 10, but in this one I'm simply left with x over x minus 4 equals 3. So let's solve this. Multiply both sides by x minus 4, or do the cross product, right? Whatever. I mean, this is basic algebra from this point. So we get x equals, let's go in and distribute 3x minus 12. Let's subtract the x. We'd have 2x here. Add 12 to negative 12 to get 12. X equals 6. Again, do a quick check, right? You could use your calculator, do ln 6 minus ln 6 minus 4 is 2. So ln 6 minus ln 2, make sure it equals ln 3, and it will. All right, we don't have any negatives. As long as our algebra is good, we should be all right. All right, that is the extent of most problems you will probably see. But I have this little bar to the right here, and I put a couple challenge problems. So, they can get a bit tricky. I wanted to take a minute. Maybe I should have created another video, but oh well. Let's take a minute and do these two. All right, log base 3x squared. So we have a property that says that it's the power rule. In a logarithm, you could bring the exponent down. It doesn't apply here because this in fact says log base 3 multiplied by log base 3x. Okay, that's log base 3x squared. when it looks like this, where the exponent is only on what you are taking the logarithm of, that is when you could bring the exponent down. Okay, so in this right one, same thing, like this here I could bring it down, this I cannot. I cannot do anything with that ln x in parentheses squared. So let's begin by doing that. And I'm gonna I'll explain why I do this next, but I'm gonna subtract 3 on both sides and get it equal to 0. So in this one, just simultaneously for that one step only, right, let's use the power rule. Okay. So why did I get it equal to 0? This again is another hidden form of a quadratic. We have something squared, right? Same thing here, something squared. We can change this to a quadratic. You always you want to make sure that u squared is that square term. So therefore u is just the log base 3x for this left one, right? So here I'm going to have u, here I'm going to have u squared. This is a much more favorable equation than what I began with, right? U substitution can simplify things so much. I love using it, and especially as you move throughout calculus, for those that will. It's a powerful tool to use in many problems. Alrighty. Well, this in fact factors u minus 3u plus 1. Okay, so therefore u equals 3 or u equals negative 1. But remember, we're not solving for u, we're solving for x. So we need to go back in and substitute what u is, right? U is log base 3 of x. Now, in this right one, I see this negative. A common mistake again is like, oh, a log can't be negative. Like that finally gets drilled in your head. You get tired of getting that wrong. But this is different. We're not doing logarithm of a negative. I'm saying logarithm equals a negative. And that is okay, because remember, to rewrite this just says 3 to the negative 1 equals x. We can do that. What we can't do is log base 3 of negative 1, right? That doesn't exist. But this is okay. Or you could do the rule that we do, right? The 3 is the base to cancel the log 3, so we just have x equals 3 to the third here. So x equals 27, or x equals 1 over 3. Definitely check your work. I'm just kind of eyeballing above, and I don't see, right? We don't have anything that would create that to be negative. So I'm going to assume everything is good, and I worked it out ahead of time, so I know it is. But definitely, again, always check your answers. Okay, logarithms especially, because the domain, it has some restrictions. We're going to use the same u substitution technique on the right side. If I say u is ln x, then u squared is ln x, in parentheses squared. Right, so if I had that, then it's still a quadratic. I don't have the constant term, right? I would just have u squared minus 2u equals 0, but we still need to solve it like a quadratic. So therefore u equals 0, or u equals 2. This term here, many people fail to remember that. I see like at this step here, people trying to divide by u or something, but notice if you divide it by u, you just have u equals 2, and you're missing the solution here. So be careful of how you solve these equations. You don't want to forget about 0. That can be a solution. So let's go ahead and substitute ln x is u, right? Ln x is 2 or 0. And notice this does in fact work because ln means e, right? The base is e to the 0 equals x. Or, again, use the trick of e and ln cancel, so raise both sides, make e the base, and you'd have x equals e squared. So e to the 0 is 1, right? I could do that. E squared, I would need a calculator. Oftentimes we'll just leave it like e squared. That's a exact answer. I'm good with that. If you plug it in a calculator, you get about 7.389. And again, looking at both of these values, if I plugged in 1, I would have positives up here that should work. If I plug in e squared, right, I'll have positives. That should also be good to go.